All right, here we go. We're going to start geometry off with tools of geometry, and more specifically, nets and drawings. A net is a two-dimensional diagram that you can fold to form a three-dimensional figure. A net is going to show all of the surfaces of a figure in one view. So if you've ever done any origami, you've created something out of paper. You've taken what is essentially a two-dimensional object, the paper, and turned it into something that's three-dimensional. Maybe a cube, maybe a bird, something along those lines. In other words, it had depth to it. So it was that three-dimensional figure. In problem number 1, the net below folds into a cube. Which letters will be on the top and front of the cube? The first thing that you should do is visualize the net in your own head, on the paper, or you can cut out your own. The next thing you're going to do is think about how the net would be folded into a cube. So we have A, B, C, D, E, and F. We have 6 sides to this cube. Now what we're going to do first is we're going to fold that D in so that the D looks to be in the front. Then we're going to move it around until we see the C. The C is actually going to be the front of our cube because that is where all of basically the vertical and horizontal lines come together. Now, what would be on top? If we rotate the cube up to show the top face, we're going to see that is E. What I want you to do now is go ahead and do Got It number 1. Once you're done with Got It number 1, take a look at the back of the book and find the answer to Got It number 1 and see if you did it correctly. You're going to do this throughout the entire year. We'll go over the problem, you'll do the Got It on your own, check the answer, and then we'll move on to the next problem. In problem number 2, we're drawing a net from a solid. So the directions are, or the question is, what is a net for the vanilla wafers box? Label the net with its dimensions. So when we see this vanilla wafers box, the first thing we want to do is go ahead and apply the dimensions to it. So it's 6 centimeters deep by 14 centimeters wide by 20 centimeters high. We're then going to replace that three-dimensional box with a two-dimensional space. So to do that, we're going to draw the lines or the edges of the box, and then we're going to rotate that so that we have a two-dimensional object. What we're then going to do is take all of the sides and basically unfold them. So you can see that we've got a side, followed by the back, followed by the other side, the top, and the bottom. Finally, we're going to label the dimensions again. The last problem that we're going to do in this section relates to isometric drawings, which show a corner view of a three-dimensional object. So instead of looking straight on at a two-dimensional object and only seeing the front of it, what we do is we rotate it 45 degrees and then we can see the corner view of it. In this problem number 3, we're asked, what is an isometric drawing of the cube structure? So the first thing that I would recommend that you do is complete the top edges of the top cube. And we can see that we've got 4 edges, where if we were looking at it from on top, we would either see a square shape or a diamond shape. What we want to do is connect the dots on the isometric paper so that we can get that first shape on there. Once we've completed the top edges, we're going to draw the vertical edges of that top cube. Once you've got the vertical edges done, complete the bottom edges of the top cube, which also happen to be the top edges of the bottom cube. We then draw in the vertical edges of the left face of the bottom left cube. Finish that bottom left cube off with the bottom left face, the bottom left edge. And then we move on to drawing the top face of the bottom right cube. Draw the vertical edges of the bottom right cube, and then the bottom edges of that right cube, and we have our isometric drawing completely done.